Yeah, what page are we looking at?
It was the last page.
Okay. Let's make sure I got it all. Looks good. And you're looking at this one, right?
Yeah.
I see. All right. So I'll say this, that I wouldn't ask you to do something this complicated on the test. Just FYI. I'm happy to do it, but I'm just gonna, what?
It wouldn't be like a
I wouldn't ask you to do something this complicated.
well, you guys know.
Yeah, I want to be upfront with something that's like, you'll see what's going on here in a minute, but it's rather complicated. Okay. So blah blah blah. We look up at some building, and we got this angle of elevation of 43. And we walk a little bit closer. And we got this new angle of elevation of 58. And we want to know how tall is this building, right? So the trick is to look at this as two separate right triangles. So we have this right triangle. And then like this right triangle. Cool with that?
Yeah.
Okay. Notice in the green right triangle, we don't know the entire bottom, and we don't know the bottom for the yellow triangle either. So what I'm going to do is I'm going to call this little piece y, which makes this piece like y plus 200. So now I have two right triangles, so I can say, if I look at this angle, I'm interested in the opposite and the adjacent sides. So I can write that with tangent is opposite over adjacent. And then similarly, I can do the same thing here. So we're looking at that angle. I want to know about opposite and adjacent also. So I can write a second equation. And notice each of those equations has two variables. They each have an h and they each have a y. So to solve this, I'm going to solve a system of two equations like we did last year in our Algebra 3-4 class. So what I'm going to do is I'm going to multiply the first equation both sides by y plus 200 to get rid of the fraction, and also at the same time get the h by itself. Similarly, I'll multiply the second equation by y, again, which also gets the h by itself. Since they're both equal to h, I can set them equal to each other. So here I'm going to distribute the tan 43 through, and then I'm going to get the y's on one side and the non-y's on the other. So I'm going to subtract the y times 43 onto the other side. In the interest of just not having to write down a million things, I'm going to kind of do that all in one step here. So I distributed the tan 43 and then subtracted y times, forgot my y times tan 43 to both sides. So far, so good?
Yeah.
On the right side, notice that both of those contain a y. So I can like factor the y off. And then we'll divide both sides by tan 58 minus tan 43. So at the end of the day, again, I just neglected to write that other side because I was being a little bit lazy, but that's okay because it's still the same thing as was before. So I have that y is equal to that. Right?
Yeah.
I just divided this quantity by both sides. So go to my calculator. And I'm going to use the fraction command so I can just type this in the way it looks. Because if I don't, I have to use like 100 parentheses and it gets pretty ugly looking. And then I'm going to check real quick to make sure I'm in degree mode, since the angles are measured in degrees there. Oops. So there's my y. And then to get my h, then I know that h is equal to y times tan 58. So I'm just going to take that answer and multiply it by tan 58. And there's my height. So 446.93 fits. Wouldn't ask you to do that in the test.
Yeah.
Just FYI. That's kind of a lot. Okay, dokie. Who's next? Victoria?
Could you do 14 on like 1 through 18?
The problem set? Yeah. Sure. You say 14? Okay. So this says without your calculator, so we know we're going to need the unit circle to do anything that we're doing without our calculator. Let me pull that up also at the same time here. All right. So what we're going to do is we're going to work from the inside out. So the first thing we're going to do is look at evaluating the arc sine of 1/2. Remember that the range for arc sine is negative pi over 2 to positive pi over 2, or really quadrants 1 and 4. Now, of those two quadrants, I know sine is positive in quadrant 1. So I'm going to go to the quadrant 1, locate where the y-coordinate is 1/2. That's pi over 6. So far, so good?
Yeah.
Okay. So now I have cosine of 2 times pi over 6. If I multiply 2 by pi over 6, that gives us 2 pi over 6, which reduces down to just pi over 3. So now I'm going to go back to the unit circle, locate pi over 3, and pull the x-coordinate, which is cosine, which is 1/2. And I'm done. Does that feel okay, Victoria?
Yeah. Also do 16.
Sure. 16 is a pure calculator problem.
Yeah, how do you do that?
Yeah, so this is really saying cosecant inverse of negative 1.5, or theta equals cosecant inverse of negative 1.5. That's equivalent to saying cosecant of theta should equal negative 1.5. Right? That's what the inverse and that statement are kind of equivalent. It's the second one that I'm going to use on my calculator. So I'm first going to change my mode to radians. From the range of values it asks me to find the answer in, it's clear that those are radian values. So I'm going to change my calculator back to radians. So in my calculator, I'm going to type cosecant in one y equals slot and the negative 1.5 in the other. Remember that we don't have a cosecant button on our calculator, but we do know that cosecant is the reciprocal of sine. So I'm just going to type cosecant in as 1 over sine. Does that feel okay? Yeah. And then what I'm going to do is I'm going to go to the window and I'm going to pick my range of x values to go from pi over 2 to 3 pi over 2. Like that. And then I'm going to hit graph. So this first line that's coming in, this is the graph for cosecant. And this is the graph for negative 1.5. And what I'm looking for is this intersection right here. So I'll do second trace, select the intersect command, enter, 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 and it tells me that that intersection is at about 3.87. So that is my solution, is 3.87. Yes?
I got it. My calculator doesn't show the same. There's not two.
There's what?
There's not two lines.
Oh, 2 parts of cosecant?
Yeah, there's only one.
Well, it depends on what your window is, like what your y's are. Maybe your y window is different than mine was.
No.
Was that the issue?
Yeah, I just don't. What?
Was your window different than mine?
No, it's the same thing. Like it's all.
Okay. Well, it should be displaying the same thing. I can take a look at your calculator in a little bit, and I can look and see if I can figure out what's going on. But if you're telling me the window's the same and you type the same stuff in, we should be both getting the same picture. So something's got to be different somewhere. We'll figure it out. Sure. I know that wasn't super satisfying, but I promise I can look at it and let you know. Jane?
I was trying to use number 22.
Sure. It says Manuel is going hiking with his GPS device. The marker at the trailhead says his current elevation is 174. Above sea level. The next marker he passes says he is now 210 above sea level. And his GPS says he's gone a horizontal distance of 1 kilometer. I'm going to write that as 1,000 meters so the units are all the same for everything. What is the average angle of incline for his hike? So we're looking for this angle here, right? Okay. Well, I can figure out this side of my right triangle because it's just going to be 210 minus 74. Or 36. Hi. Does that feel okay? And then I can just use tan inverse because I know the opposite and adjacent sides. So I'll put this back into degree mode since my suspicion is that if you're asking for an angle, you'd be wanting a degrees not a radians if we're talking about like hiking. You're like, oh, I just went up a 4 radian grade. What the heck does that mean? Nobody knows. So 2% or 2.06 should be our grade.
That one was as far as like, I didn't know how to draw it.
Mm-hmm.
So would there be one similar to that?
Sure, it could be. I mean, it's just a right triangle drawing. There's no like weird system or anything to solve. It was just, you had to subtract 2 numbers to get one of the side lengths, which feels like that should be within our capabilities, especially now that we've seen the way to draw one of these things, right? It should kind of have like a trapezoidish thing, and you just have to like lop a triangle off the top of it. Is that cool, Jane?
Yeah.
Yeah. So this is, I think, is a realistic problem for you guys, as opposed to like 23, where you're going to end up with some like kooky system to solve. Others. Emilio.
On the review, can you like 4.1?
What page are we looking at?
Page.
Page 3. Okay. So this is just like what we did in worksheet 2. So I'll start by looking at the range of thetas to draw my picture. So because theta is positive, I'm going to be going counterclockwise. So our answer needs to be in quadrants 2 or 3. Using all silly turtles crawl, I can tell that sine is positive in quadrant 2. So this is the theta that I'm looking for. My alpha is here. Since the last axis that my theta passed through is vertical, I'm going to be subtracting alpha. And I'm going to be subtracting alpha from the other part of the x-axis that makes up alpha. In this case, that's pi. And alpha is then sine inverse of the absolute value, 0.31. So go to our calculator now, change back to radian mode. You guys are giving me the runaround here on switching my modes around, but that's okay. It's good practice for us to remind us come test time, you may have to be really careful about your calculator mode. And I did the absolute value in my head, right? There's no sense in wasting the buttons to put it in your calculator when you can just make everything positive. So I have 2.83. Does that feel okay, Emilio?
Yeah.
Okay. Jane. G from the first page. This one? Okay. So here we're not given a range of thetas. So we're going to have to use the fundamental range for tangent inverse, which is negative pi over 2 to positive pi over 2. So 0, if it's negative, I'm going to be going clockwise down to pi over 2. But if it's positive, I'll be going counterclockwise up to pi over 2. So we're really talking about quadrants 1 or 4. If we do all silly turtles crawl, I see that tangent is negative in quadrant 4. So we're talking about that angle there. Okay. So this asks for an exact value. So I remember that tangent is y over x. So I'm going to be basically going to my unit circle and looking for the place where the y coordinate is root 3 and the x coordinate is positive 3. But there's no place on the unit circle where has any coordinate with a regular 3 in it. So I know I'm going to have to do some reducing here to make this work. I remember the square root of 3 is really, or regular 3 is square root 3 times square root 3. So I can reduce that down to 1 over square root 3. So what I'm going to be going for is the place in quadrant 4 where the y has a 1 in it and the x has a root 3 in it. So y has a 1 in it, x has a root 3 in it. We're looking at 11 pi over 6, but that's not our answer. Because, that's embarrassing. Because that is not inside of our range. That's in the terminal side of our angle is in the correct location, but the actual value of our angle isn't inside of the range we're looking for. So to fix that, all we'll do is clearly 11 pi over 6 is too big. That's pretty close to 2 pi. So I'm going to just be subtracting. So to find something coterminal to this angle and smaller, we'll be subtracting 2 pi. So when I make my common denominators and all that good stuff, my common denominator is 6. So 2 pi becomes 12 pi over 6, which gives me negative 1 pi over 6. And that is inside of the range that I'm looking for. Does that feel okay, Jane? Yeah. On these kind of problems here on the first page, if you're dealing with a sine or or tangent problem, and you're looking at quadrant 4, if your answer is in quadrant 4 for either a sine or a tangent problem for these types, you're going to have to be subtracting that 2 pi at the end, just so you know. The cosine you won't have to, because cosine is its range is 0 to pi. So you can just read those values directly from the unit circle. You don't have to worry about anything. But sine and tangent you have to be careful about if you're reading from quadrant 4, that you really want the thing coterminal to that. So you're just going to be subtracting 2 pi every time.
Okay, and then will we be given the ranges for
Yes. Yes. So how did I do that? Let me look real quick. Just so I can show you what you're getting, right? Yeah. Is that on the review?
Yeah.
Okay. Yeah, so this is what you're going to get. So this at the bottom of the review is the same thing that's going to be on the test at your unit circle spot. So you'll have that information as well. Victoria.
On the same one, like G, why did you choose quadrant 4? Because oh wait. Yeah, why did you choose quadrant?
Because tangent is negative only in quadrant 4, because all of them are positive in quadrant 1. Cool? Okay. Yeah, no problem. Domenico, I have a slip for you. You get to go someplace at 8:45. Yeah. It's good to keep you awake till 8:45 so you don't miss your meeting. Gotcha. Zinged. All right. Who's next? Do we need to talk about anything else? Landon?
It's just like a logistic question.
Sure.
Over like how many questions of each type.
Yeah, I actually have this already posted on OneNote. So this is the kind of the test question format here. So I typed this up and it's already on OneNote. So we have 2 questions where I'm going to ask you to use your calculator to find the inverse. So pretty much you just type your stuff into your calculator and write down the numbers, right? 4 questions where I ask you to find the exact value for an inverse. So that's like the first page of the review, the questions that we're just talking about. 2 questions where we ask you to use the unit circle to find the exact value of like a nested inverse trig function, regular trig function. So that's kind of like that question that Victoria asked over here where we have like an inverse and a regular trig function that are kind of like one inside of the other. So kind of like what you did right here. And I think there's a whole mess of these questions on the review also, right? So you have 2 like that. 2 questions where we ask you to use your calculator to find the inverse over a specific interval. That's like all of what you did on worksheet 2. Those are like the worksheet 2 problems, the same kind of problems we did on the homework quiz. 1 question where I ask you to solve a right triangle. So you just find the missing side lengths and angle measures. Very similar to what you would have done inside of some of these story problems, except you already have the triangle and all. You don't have to decode anything. You're just doing the trigonometry part. And then 2 story problem questions that won't involve solving systems. You guys feel like you got a pretty good picture of what to expect there? Okay. Cool. And this is obviously, that's in the content library, so you can access that at any point.
Thank you.
Yeah, no problem. All righty. Should we start talking about chapter 5 ski? I mean, probably not, but we got to do something, right? So let's do this.